In this video, we're going to take a look at the dynamics operator called follow. Follow is used for particles to follow a node in scene. You can see out here we've got a point helper with some keys on him. He kind of runs around, does some rotation, and heads back out. And what we're going to do is born a bunch of particles onto this plane. So we'll go ahead and create a first rule. We'll add a generator, matter waves, and we'll pick that object there. And we're going to go ahead and change the way that matter waves borns particles. Go ahead and set it to a rate of 10. We'll set their lifespan to be 10. We want their speed to be 0 at birth, so it's just going to create them on the surface. And we'll go ahead and randomize the UV emission points. Then we're also going to add some shape to those guys so we can actually see them. We'll add a standard shape size shape black box that we had. And hold Alt and right click that geom instance to get rid of it. Okay, let's see what we have. Let's make the size a little bit bigger. You can tell master dynamic edit on the fly is turned off because as we scrub these parameters we see the change. We'll go ahead and create another rule now, and we'll scrub and see that we get a bunch of particles being born. And in this next rule we're going to name this follow. And here in follow we want to affect the all group. We'll come over to operators, into the dynamics category, and add a follow. You can see follow's got two inputs he needs. He needs a particle to affect, and he also needs a node to control that effect. So we're going to add a helper, a node, and make that connection. Okay, and follow has two different methods it can use, type 1 and type 2. They're both very useful. They just give kind of different controls, and obviously type 2 has quite a few more. Let's go ahead and see what happens right away as we do this. Well, you see nothing happens, and the reason for that is because our node still needs it to be picked. So let's go ahead and pick that point helper. And now as we do this, we can see that these particles are, what they're doing is they're inheriting the current velocity and rotation alignment of that source node. Okay, so one of the things that we can do to add some variation there, because you can see they're following very stiffly, maybe what you want, but just as far as extra controls, we can adjust the speed value. We can decrease this to kind of add some lag to them so they don't actually start off or follow at 100% speed, so you can see some secondary motion in there. We can also, let's go ahead and set that back to 1. Something else we've got is position dependency. Position dependency looks at how close each of the particles is to that node and can kind of fade off the effect based on that, control the strength of it. So we'll see here, let's get a little bit further. You know what, let's change our matter waves. Let's go ahead and switch to pistol shot. So it's actually going to born all those particles right at once. And then we're going to come into the follow node and we're going to set our position dependency. We're going to increase this and see what happens. Position at 0.41, you can see very little motion, so let's go ahead and decrease it until we can kind of sculpt the effect that we want. And what we see is that these particles who are closer are getting more of the follow strength applied to them. So that's what position dependency will do for you. Let's go ahead and switch matter waves back to particle per second rate, and on follow let's take a look at particle life dependence. Particle life allows us to define the strength of the follow node over the particle's age or lifespan. And let's go ahead and see. Now our matter waves is set up so that these particles have a lifespan of 10 seconds. Our time configuration max we're set to NTSC, and we've got 300 frames, so this is in fact 10 seconds. And what we're going to do is in follow, we'll go ahead and say at particle life dependency, when you're born, I want you to go ahead and follow the effect very strongly. And then toward your death, we don't want you to follow this effect at all, so we'll just go black. So they start off, and then they just kind of start to lose it. They just follow less and less. Okay, so let's reset that particle life dependency. And now something else that we have in type 1 is something called catch. Now catch is actually kind of a tension parameter in between the particle and the node. If you start to decrease this, you'll actually begin to add some extra springiness into the effect. So you can kind of see them fluttering around a little bit there. Let's actually decrease this more and we'll get a stronger spring effect, or a looser spring if you will. And you can see them kind of pulsing around, getting close, getting far. So that's just another available option you can use. And you can control the strength of that, of course, in the same way as the speed with position dependency. So particles who are closer are going to have it looks like a stronger catch effect, or a looseness. Okay, well, enough of type 1. Let's go ahead and switch to type 2.